Hello everyone. Today we are going to discuss the subject measurement and instrumentation. Under this measurement and instrumentation, we are going to discuss the topic electrical and electronics instruments. Myself, Dr. I. Bharanilingesam, Assistant Professor in the Cadre 3, Department of Electrical Electronics Engineering, KBR Institute of Engineering and Technology, Coimbatore. So, this unit consists of the following topic: construction working principle of the moving coil, construction and working principle of moving iron instruments, dynamometer type wattmeter, single phase induction type energy meter, digital altimeter. Under this digital altimeter we are going to discuss about two topics. One is that integrating type digital altimeter and another one is the successive approximation type digital altimeter. And finally we are going to discuss about instrument transformers. So this comprised form is known as our unit 2. This unit is called the electrical and electronics instruments. Classification of measuring instrument. The instruments are classified into three categories. One is that mechanical instrument, electrical instrument and electronic instrument. Again, the electrical instruments classified into two categories. One is that absolute direct, secondary direct. These secondary direct instruments classified into two categories. One is that analog instrument, another one is that digital instrument. Analog instruments again classified into two categories. One is the deflecting type of instrument, another one is the null deflection type of instrument. This deflection type of instrument classified into three categories. One is that indicating type instruments, integrating type instruments and recording instrument. So these are all the various classification of the instrument, and most importantly we are going to discuss about two topics here. One is that moving iron type instrument and moving coil type instrument. Moving iron type instruments classified into, there are two types are there. One is that attraction type, another one is the repulsion type, where in case of moving coil type instrument classified into permanent magnet type, another one is the dynamometer type. So these are all the classification of the measuring instrument. So principle and types of analog to digital altimeter. Basically an electrical instrument is divided into two types. They are, one is that analog instrument, another one is a digital instrument. Analog instruments are nothing but output is the deflection of pointer, which is proportional to the input value, where in case of digital instruments are the output in the form of decimal. Analog ammeter and voltmeter are classed together as there are no fundamental difference in their operating principle. The action of all ammeter and voltmeter, with the exception of electrostatic type of instrument, depends upon a deflecting torque produced by an electric current. In an ammeter, this torque is produced by a current to be measured. In a voltmeter, this torque is produced by a current which is proportional to the voltage to be measured. Thus, all analog voltmeters and ammeters are essentially current measuring devices. Okay, so in this topic we are going to discuss about moving coil instrument, which is based on the permanent magnet type. A permanent magnet of moving coil instrument is the most accurate type of the instrument for DC measurements. The working principle of this instrument is the same as that of the d'Arsnoval type of galvanometer. The difference being that a direct reading instrument is provided with a pointer and a scale. These instruments works on the electromagnetic effect of current. A permanent magnet used to produce a magnetic flux and a coil that carries a current to measures the moves in the field. Simply we can say it as a principle of the moving coil instruments are nothing but when a current carrying conductor is placed in a magnetic field, it is acted upon by a force which tends to move it to one side and out of the field. This movement of the coil used to measure the current or voltage. So this is the principle of the moving coil instrument. You can see this diagram. This diagram consists of the various parts. One is that moving coil, which is having north pole, and permanent magnetors are there which having north pole and south pole, and we have a moving coil mechanism, spring mechanisms are there, the jewel bearing setup also there, and we have a pointer, scale, everything is mentioned in this diagram. The working principle When a current carrying conductor is placed in a magnetic field, it experiences force by the following expression: F is equal to BIL, where F is the force in Newton, B is the flux density in Tesla, I is the current is ampere, L is the length of the conductor in meter. The current which is to be measured is passed through the moving coil and experiences a force which is directly proportional to the current. Due to this force of the coil moves and the pointer attached to it also move. The angle through which the pointer moves proportional to the current flow. This is a simplified diagram of the permanent magnet moving coil instrument. It consists of, as like the previous diagram, it consists of permanent magnet, pivot and jewel bearing setup. Again we have a balancing weight, pointer, and the pointer is directly pointed out to the scale. Under the scale we have a mirror mechanism. In order to prevent from the parallel axis, we are using mirror in the voltmeter or ammeter, and we have a spring mechanism also in the case of permanent magnet moving coil instruments. Construction of the permanent magnet moving coil instrument. The moving coil is wound with the many turns of enameled or silk covered the copper wire. The coil is mounted on a rectangular aluminum former which is pivoted on the jeweled bearings. The coils move freely in the field of permanent magnet. The voltmeter coils are wound on a metal frames to provide the required electromagnetic damping. Most ammeter coils are wound on a non-magnetic formers because coil turns are effectively shortened by the ammeter shunt. The coil itself provides the electromagnetic damping. Construction. The instrument consists of the permanent magnet which is shown in the diagram and a rectangular coil for turns on a light aluminum or copper former inside which is an iron core. The sides of the coil are free to move in the two air gaps between the poles and the core. To the moving coil spindle is attached. A pointer is attached to the spindle to move over a calibrated scale. Working principle. A magnetic field or sufficient density produced by the permanent magnet. The moving coil carries the current or a current proportional to the voltage to be measured. Hence, electromagnetic force is produced which tends to act on the moving coil and moves it away from the field. This movement makes the spindle move, and so the pointer gives the proportionate deflection. There are three torques are acting in the moving coil instrument. One is the deflecting torque and control torque, damping torque. Deflecting torque, it is directly proportional to the current or voltage to be measured. So the instrument can be used to measure the direct current and DC voltage. Next we have a control torque. The control torque mainly focusing on the spring control. Next we have a damping torque, eddy current damping. The damping is electromagnetic by eddy current induced in the metal frame over which the coil is wound. Since the frame moves in an intense magnetic field, the induced eddy currents are large and damping is very effective. Errors in permanent magnet coil instrument. The main source of errors in moving coil instruments are due to weakening of permanent magnet due to the aging effect and temperature effects. Next one, weakening of springs due to aging and temperature effects. And third one, changes of resistance of the moving coil with the temperature. So these are all the possible errors can occur in the permanent magnet moving coil instrument. And advantages, disadvantages of the permanent magnet moving coil instruments are: the scale is uniformly divided. And the power consumption is very low. The torque weight ratio is high, which gives the high accuracy. A single instrument may be used for many different current and voltage ranges by using different values for shunt and multipliers. Thank you.